Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity, and one of the things we want to do is support the metadata. Now, this is not software metadata. This is metadata about the tunes. So it's things like the title and the origin and things like that. And we have some of it, but we've needed to capture the metadata that's inline. So you can be in the middle of a bunch of notes and add some metadata. And it's a totally different syntax. It's got to be handled a different way. And along the way, we had a type alias for metadata that just said, oh, it's a map from strings to strings. And the strings to strings part is okay, but we need more stuff from it. We want it to be a little smarter. So we started converting over the usages of it to a new object and found about, I don't know, 30 or whatever places where it was affected. And I got called away because my daughter had a false alarm for labor. So she's supposed to deliver sometime in the next whatever. But we're in the middle of this change, unfortunately. And then I just noticed that as I brought up Xcode, it was saying, oh, we're updating. So I don't know what we're going to have here. But we'll get started and see what we got. Okay, Xcode, where are you? Okay, he might open. So my hope is we can finish the metadata today or at worst tomorrow, and then I want to move on to clustering. Okay, all right, so cannot assign through subscripts. All right, so our original metadata is a simple array, simple key, a map, I guess you'd say. I want to call it a hash table, but we don't say that in Swift. And so there's no subscript that we can assign through, and we can't check either. All right, so we want to handle this, and then I think there are a bunch of tests that are going to complain once we got that. But this is easy, and I looked it up, so it's even easier. Subscript method, you give it the argument of the index type, you give it a return value, and then you can give it gets and sets. All right, so let's just take this. We'll modify it all over the place, but it gets us started. All right, so metadata. Okay, so it was string to string. We did subscript index of string. Let's do this. Returns a string. And our get is this. And our set, I think I needed another brace here. Let's format that. Something's missing. Can I find image star? No, we can't. Let's do data sub index equals new value. Okay, so I think that will be enough. This should come off. Data sub index or empty string on a get, and then okay, so we always are willing to pretend there's empty data. All right, now tune metadata sub index. Okay, so we don't need this part anymore because we do it. Oops, unexpected bracket. There's that one. How did I lose this one? Okay. Optional type string. That sounds like it's not quite, hasn't quite built this. There we go. Why is that optional? I think maybe it's slow. I hope. I did promise to return a string. Cannot find metadata descriptors. Oh, I think maybe this. I think these were outside the class. Yeah. Okay, let's build again. Oh, I'm screwing this thing up major. Okay, can't find metadata descriptors. Some type of string. No, that doesn't. Well, I hate being so paranoid on the compiler, but metadata is it really metadata? Yes. Well, I'll put this back how it was. That's that one. This one. Metadata. Okay, yeah, now we're getting... This really should be, we got to provide a constructor for it. All right. Now, it's odd to me that this thing is using that. I'd really rather not have it, but you're behind. Okay. And so we need a constructor, and let's make it data of type string to string equals nothing. Okay, so that should be the same as we were. And that should be better. I think we'll get to tests that are failing now. I think that message is probably old, seeing as it's saying, no, build succeeded. There it goes. Okay. Now I'll run tests, or I'll build tests and find out that they don't quite work. All right, cannot convert value of string to string. Okay, so we need to wrap these just like we did the example above. I guess I can use that much. Yeah, it's like I feel like that constructor should really be part of the test, but we did use it for the preview. I don't think it's so terrible, but I don't think real uses probably will come in with this. But on the other hand, it's not a high price. Surprised these need... I guess we're kind of creating a tune with certain metadata. Right. Yeah, that's what it is. We're creating a tune from scratch. You got to give it metadata and you got to give it parts, and ID and title are required, I think. Although, yeah, because we're going to pull those out. Okay. Yeah, I guess I can accept that. It seems like a lot of places doing this, but really, I should have done this earlier. When I had the type alias, I can use it as a constructor, and if I had done that, well, it might have been okay. It might have been good to recognize, like, hey, this is really looking a lot more like its own concept if you're using it all over the place. Did we miss one? Okay, we'll do another clean. Yes, don't ask me when I want you. If I tell you to do it, it's probably because I want you to do it. All right. Let's run these tests. Theoretically, nobody should be changed by this stuff. In reality, we'll see. So much for that theory. Okay. It seems to be a number of places. In tune body, yeah, that should a semicolon. Oh. Okay. So, oh, wait a minute. Okay, so somebody's appending that semicolon. It really should be done in here. I don't know if we can see these. Last week I would have remembered where it was, but this week, no chance. Okay, so tune. Here we go. Okay, yeah, so we have put. Oh, yeah, okay, so it checks the key for nil. All right, maybe this should not be added just yet. That may throw somebody else off that was looking for it. That's going to assume it's empty. Okay. Total no scan. We deck the halls. Tune 1, tune 2. Filter text deck the hall. So that should be contains. Okay. What else we got? Soundstage. X0, tune 0, X1, tune 1, stage dot options. I don't know. That looks really odd. Field shows alphabetically with count. Okay, whale, cat, whale. I don't know what the counts are. Oh, okay. We had 2 whale songs. Count 3. Tune sim field count value. Empty string. Okay. All right. Apparently I should have just reverted the other day. Let's look at the colors of this again. Maybe I should yet. I don't know. Metadata key equals nil. Okay, well that's good. Metadata key equals value. Else metadata key. Okay, these all seem, I mean, this method should be over on metadata and we're working towards getting it there, but that seems fine to me. If it's empty, I mean, we could do it with an empty string, but we haven't. Okay. This passed. That's our thing. That's that. Right. We saw that we were duplicating that in the first place. It's kind of what got us fixing this. Parts. Well, oh, that's a little different. Titles equals empty. Otherwise, take title sub 0. Okay, that seems okay. Right? All right, try this again. I feel like debugging one of these things will probably reveal it, but I don't know. Well, that's true enough, but that's not a problem. Okay. We got soundstage. This is the one that plays the melodies. Okay, tune 0 with ID X0, tune 0. ID X1, tune 1, 2 tunes in there. When we consume the packet, well, let's look at consume. Okay, so soundstage, what does he do? He takes the tunes, he maps them based on selector of $0. Okay. So basically take the tunes, look up the ID, look up the title, All right, let's break here. And this test is place selected tune. Okay, so let's print the tune. Well, okay. I guess we're going to have to back up. Yeah, that's going to be empty. It's got no metadata. All right, that should not happen. Assuming our input is correct. Let's go check, go run it again. Metadata 0 pairs. Okay. Right. Okay, so something is not set up in our tunes when we get here. So let's go back. Tune metadata. Well, we'll break here. Yes, setting up tunes is not going well. Okay, tune. Metadata equals blank. But he sure seems to be passing something here. Okay. All right, so let's see the metadata. Empty. Well, that seems very odd to me. He's got metadata, he's got parts. Okay. That's really... Okay, let me do a clean again. All right, we'll run this. Oh, too weird. Okay, what is going on? And am I where I think I am? It's this line. We'll start with this. Okay. Equals the old. We'll check here and then check inside, I guess. We didn't assign it in our metadata. Yeah. Ding dong. Okay. Data equals data. And run all tests. Well, where's that error? Let's fix this while we're... All right, do that again. Okay, add metadata class, make callers, use it. Okay, I might have been better off the other way, but we have, let's see our metadata class. Okay, so we have this. I don't particularly want to expose set. I don't know if I can tell who uses that. Oh. Nobody. Okay, I don't believe it. Okay, thank you. And it's not finding what we want. I can use this though. Okay. Event to parts. Okay, now my theory is we should be able to move this function over. It's only caring about metadata and its arguments. Okay, so let's put this on metadata. I'm kind of going to do this a little on the slow side. Okay, cannot find metadata. This is just data for this class. Okay. And back to parts. All right, so who calls this? We're going to make them call the metadata version. Really? Oh, there it is. Okay. Metadata key value. But I think we have metadata somewhere here, right? Metadata. Okay. So we can tell metadata to put that. Everything should be okay. All right. Make metadata provide put. Okay, and then theoretically nobody's calling this now. It was public, so maybe there was a function out there that does, or a test. Nope. Okay. And if we go back to, well, let's go to metadata subscript. Okay, so this function we copied over the other day, I believe, and it's identical to the one we have, barring name change. Okay, oops. If it's nil, set the value, otherwise append. All right, so let's find who calls this one. Oh, tune builder. Oh, this is the one that counts. Well, tune builder last is a tune builder. Okay. So, well, let's move this to metadata. Doing that rather than exposing metadata to the callers directly, I think that's better. Tunes Builder doesn't need to worry about Tune owning metadata, but it does want to say, hey, you should have this key value pair in there. All right, let's make sure that rewrite. This is Tune Builder, right? Okay. Now, all right, let's keep looking for those usages. There's the put. People are doing that. Okay. Yeah, that's really a question of, well, it's kind of an indirect testing of our metadata function, I guess. Making sure it was involved more or less. All right, let's go back to metadata. Metadata. I'm going to make this private. See who breaks. No. Well, I guess I'll just see who uses it. Okay, that's a get. That's us. Get tune builder. Well, I think for these we should be using metadata.put. Yeah, I think if I have a bare bracket, I kind of don't want to assume it's modifying the thing I put in, whereas put, I don't know, it just feels a little more flexible. Or I guess the meaning feels more like I wouldn't be so surprised that put has its own feelings about how to put these things. Let's see if these work. Okay. Okay, I'm not liking that line, but you know we've been doing things. Let's get this. Okay, this is what we've really been doing so far, and let's capture that here. April. Ugh. Metadata should be in its own class, but put there. Yes, that's true. And I think now we're well. Let's say use metadata consistently. I think. All right. So now we use index. We don't use the subscript on self. Okay. So I can get rid of this and that. Okay, I think that should be consistent with the usage at this point. Okay. All right, that's a little bit of a programmer name, but all right. And now, oh, I lost it. I've got too much stuff. All right. Let me see, parser test. No. String field tests. Tunes builder. No, I want tune builder. Okay, these may be interesting to us. This I don't think is. Event to parts. I believe we've added our metadata here. Oh, interesting. Metadata with anything says just put the metadata in place. Okay, so I think we're doing what we want to. This one bugs me because the separator semicolon, that's really a decision that metadata is making. All right, so I think what this should be is titles dot for each metadata dot put titles with the title. So rather than me joining them into one giant string and then appending it to the metadata, I'm just telling the metadata, add another title. For each title in there, add it to the list of all titles. And then this should be not there now. All right, so okay. Make metadata compute semicolon in titles, not its color. Okay. All right. Now, I believe we have a test that's commented out. Is this one disabled? No? Okay. This is where we started our journey last week. This is inline in tune body. So I'll go back to the standard. You have these information fields, and you have a tune header area. So you got the title and so on, ID, and then title, and then a bunch of stuff and a key number. Any of these can be a line in there, including like remark. And let's see, so he can be, we're not doing file header, but he does tune header. Yes, he can be there, or he can be in the tune body. So after you start writing the notes, A, B, C, D, E, F, G, you could put another line in there that says remark line, and then go on to the next line of notes. And the remark would be captured in the metadata, but not really involved with the notes per se. But those both can be parsed at the top level. But if you allow it inline, it goes inside brackets, and brackets are really overloaded in this thing, ABC notation. So it could be a chord name, it could be a vertical bar, but like a bar separator between measures, or it could be an inline instruction, in which case we want to capture it. Okay. And that requires modifying the sort of note parser to be aware that, oh, there could be an instruction coming in the middle of this thing. All right. And that's what this test is doing. Let's just run this one. I don't know why I didn't have a green mark. Okay. This does fail. Is this disabled? Oh, it is. Okay. Sorry. Yeah. Now we got everything in place that we should be able to fix this test. All right. We did not get body remark in the remarks. Okay. And whoops, what was that? Somewhere there's another failure. This is the line that failed when we tried to parse the tune with R. Let's see, is this right? Okay, so we're passing in a pair for the input, and that's the input.0, input.1. So we're saying R colon body remark in here. All right, now let's go to a note line parser. I don't know if we allow it yet or don't allow it. I've kind of forgotten. Inline field letters, so that certainly seems okay. Inline field letters. Okay, so this says I'm trying to build a bar line. If I see a left bracket, I only accept it if it's not followed by an inline field like R. Okay, but do I have something that accepts those? Let's find the usages of this. Ignoring case. Really, how weird. Okay, but I can see it's not used other than excluding. It's not used to include anything. All right, so let's go back to event to parts. No, Is that right? Yeah, we saw that somewhere. Where was that? A metadata. Okay, yeah, let's see who calls this. Well, let's look for dot metadata. Whoops. We should find a test. Event to parts test would be a good one. Yes. Okay. Metadata events are put in the metadata result. So what we've done so far is we said if somebody creates a metadata event, we actually handle it correctly. We put it in the metadata object associated with it. Okay, so here we're creating event to parts, no existing state, no existing metadata, or default state, no metadata, and a series of events, including one metadata one. And when we look after that, it has updated the metadata, the output metadata, to say it is processed. So my conclusion is this thing should put out an event for that. It does not yet. Okay. Oh, interesting. Here's instruction. Remark. Right. Okay. It just says return empty event, an empty array of events. You can see here the key change, that's K colon key of C, and it puts in a key change event. And this one puts in a note length and a meter change. We did the work to set it up, but we didn't actually put in the event yet. Okay, so this thing, well, we match the R and skip it, match the colon and skip it, and then everything we're matching up to the bracket is the contents of that thing. Okay, so this underscore is throwing away those contents, but let's say value in. All right, and then we need to produce an array of events. Well, it's going to be metadata. Well, it's going to be our event metadata key value. This metadata, and the key is remarks, and the value is the value. Okay, so we're putting, well, I guess I have to be specific. Okay, we're returning an array because some things return two events, multiple events. But in our case here, remarks value. So I believe, string. All right, this type is array of characters. Satisfy character is dot target is character. So array of characters. It's all an array. Okay, so it matches individual characters. We put it into a string, and I think that's going to make our test pass. What do I know? All right, parser tests. Empty string is not. Okay. And we parse tune with this stuff. We've got a space before the bracket. I don't think that should hurt it any. We should get R colon remark. And then ABC, and our expected is remarks should be equal to body remark. Okay. So parse tune. Well, let's see if we're getting here. think we lost value. Yep. Okay, let's just continue. Whatever. All right, let's try that again. Okay. Maybe I can step into. No, I can't. All right, I'm going to set up a different function for this. Okay, that's make. Let's go. This is remarking, and it's going to need an argument that's array of character, and it produces an array of event. All right. $0 is the array of characters. All right, this gives me somewhere to stop. All right. Assuming it gets called. If it doesn't get called, we know there's a problem. Okay. Okay, well, that's a remark, all right. Event.metadata. These produce theirs. This produces its instruction. Okay. So inline field produces event, array of events, which should come out to here. So we're in the middle of ParsonsCode. Okay. Let's continue. I mean, it looks like it's grabbing the right thing. And make sure it's doing the right thing with it. Event, metadata remarks, string with those characters. Make sure the test is looking for remarks. Yes. Okay, we'll continue. Unexpected characters 4-3 R colon. Line 4, column 3. Well, ParsonsCode adds some stuff, but 1, 2, 3 is this bracket R. Okay. That makes me wonder. I don't know. It's expecting. Oh, it's not equal to empty. Okay. So it got this message, but it expected an empty list of messages. Okay, that's better. That, well, I don't know what to think. Our colon, it called our method. The only thing I wonder is sometimes I think we may have a situation where when it tries alternatives, there's two options. One's backtracking and one's not backtracking. Let me see. This is where else? Oh, let's look at this. Right. So let's see. See, this one is or else with backtracking. And I think what can happen is if it matches this, when it matches something, if it makes any progress at all, it's kind of committed to that path unless you make it explicitly alternatives. So I think that may be the problem here is that the all note parser can get in, see a bracket, try and treat it as part of that bar line parameter thing, because bar lines are handled in here. And then it says, well, you got as far as a bracket, but now I don't know what the bracket's doing there. And it shows the three characters. So bracket R colon kind of tells me it didn't know how to interpret that. So let's try this. It's getting into the subtleties of the grammar, which it's that ambiguity I talked about, I think. Now he does get here, but he can throw that stuff away. Oh, okay. Is that what I already had? No, I think I'm in trouble. Okay, well, I heard the clock, so I think we'll take a break, just 3 or 4 minutes, and come back and we can see if we can figure out why the parser's not happy with that thing. All right, see you in 3 or 4 minutes. All right, welcome back. Let's see. So what we tried was making these back up. I think well, okay, I saw something that I think is the issue. Let's see, where's that remark parser? Okay, yeah. Our inline field says match a left bracket, match a right bracket with the instruction in the middle. This thing says, hey, I need to match a right bracket. So I think we're trying to match it twice. All right, so I think that's part of it. I'm not sure about that backtracking thing now, but this should match the R, skip that, match the colon, skip that, and return everything that's not a bracket. And then its caller, grammar caller, will match the bracket for it and again throw it away. So the instruction's the only thing that should come out. All right, so I'm too burned to say I think it'll pass, but I do hope it will pass. Okay. Yay. All right. Now let's figure this out. All notes parser. I think the fact is inline field. Well, are these right? I think inline field really should be our first consideration. That, well, it comes before bar line, so maybe that's not a problem. No, I think this using this optional or backtracking one is actually correct in this case and necessary, because all notes parser can have chords which have brackets, and if we've matched a chord, then if we start matching it and it turns out to be a chord, we thought it was a chord but it isn't. Oh, well, maybe it's a bar line followed by a letter, and we want to make sure that we get around to that alternative in the end. So I think this is okay. All right, so let's see. We handle our for remarks on for inline remarks. Okay, now I guess I think we did that. And I think we handled remarks. And now we need to go on to the next one. Let's do notes. Okay. I expect this to fail. Oh, I should take care of that remarking method too and inline that again. Okay, did not get captured. And no line parser. All right, so let's well, maybe how about capture inline metadata with field name and characters. Okay, and this should be field name and the call is down on remark. Oops. Capture inline metadata for remarks in $0. Okay, that's same two failures, but now we have okay. We see the pattern, and not that is notes. I'm going to rename this one inline notes. Okay. That's probably still accurate. Okay, so rhythm. And rhythm is things like real. Okay, so it's sort of a free text description. It could be a reel, it could be a slow rock, it could be whatever. Oh, we don't need that anymore. All right. And that's also a noteline parser. Let's get the test first. R is a hornpipe. We expect a rhythm hornpipe. All right. We'll fail. Okay, this is inline rhythm. We'll match an R. Rhythm. I think we called it that. And remarks, and we should. Okay, should pass. All right. Did I do? Yeah. Okay. Alrighty. So all right, let's close a bunch of stuff. All right, what I want to do next is this clustered notion. Okay. And so what happens, let's just run this once and take a look. We'll just take our moderately big Noscalan, deck the halls. All right. I guess software expectations would be a concerning thing. All right. Thanks for joining. All right. So we're just switching gears to a new topic. So what I've got is I've got a set of tunes in what we call ABC notation, sort of like just the letters of the notes, but there's a bit more to it. And we've converted them to ParsonsCode, which just is this string of it's star is always the first, and then it's either down, repeat, or up. And so this song goes down, 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 up, down, whatever the Deck the Halls song goes. And we do that for each of these versions that a musicologist has collected. And they're trying to find the similarity or differences between them. And this view, it doesn't tell you if they're going up by the same amount between two songs. It just says kind of the general shape. You get these little mountain ranges like this. And once you've got them in this list, I've just sorted them. This is 4 Ds in an R, 4 Ds in an R, 4 Ds in a U. Okay. So they're it's a very primitive sorting thing. And you can see that this one is, well, it looks pretty similar to this or maybe this. They don't look like this at all. They don't go down, 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 down. Okay. Those two might be a little closer and stuff, but we've got some plausible ones that look a little more like the first ones, but it started with R U U, little differences. And again, same here. This should be clustered very close to this, but sorting it by character kind of privileges the first few characters. And so even if you were completely the same general shape, you wouldn't show up very close. All right, so what I want to do is I'd like to have a different version of this display that takes these things and compares them pairwise. So this one versus this one, how close are you? Well, for the notes you have, he looks very close to me. Maybe he's identical up to here. I don't know, but he's very close. And if I laid them over top of each other, I want to measure kind of the area of difference between them. Okay, so this one, I suspect this fragment is coming from here, but version 1, we won't be able to tell. We'll just say like this one mostly goes bouncing around and this one goes up, 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 up. And so they're going to be more different. Whereas this one versus the first one, it's close-ish, but not identical. Okay. So the first two maybe should be really close to each other. This one kind of medium, this one a little further away, and then these down ones like way over on the side. So what I want to do is compare them pairwise, and I'll get a distance for each one. Basically, I'm going to subtract, did you go down or up? And if they're opposites, it's a difference of 2. If one's a repeat and the other's an up or a down, it's a 1. And if they're both the same, it's a 0. So I'll measure this distance between each ones, and then I'll say, if I gave you a list of distance pairs, and I told you to arrange it in a plane in a way that made those pairs kind of reflect each other as well as you can. It can't be perfect because this is not a 2-dimensional measure, but there can be some, I think of these kind of gravity type situations. The two that are close should be very strongly attracted to each other and close to each other. The medium one's further away and kind of clusters visible. All right. And I kind of have, I have a pretty good idea how to compare these things. Version 1, just do this sort of diffing. Version 2, I might consider sliding as if they were transparencies over each other, sliding them back and forth and find the spot that matches the best. And then there may be other measures that somebody could suggest, but I think one of those two measures would be worth exploring. And then the clustering or the placement algorithm, I don't really know. I know there are algorithms out there, and I did a little searching. Let's see, where is that? Oh, this thing. I caught a couple in Pocket. No, I didn't. Okay. I didn't catch any in Pocket, but a little bit of searching. And I did a study. I don't know what they do for that stuff. It would be an indication. I think what happens is you get these indications, and if the melodies had similar shapes, they might be jumping around differently and they might count as different melodies, but it also is suspicious if it's exactly the same shape, right? And they also might say, like, let's look at the chord structure of the song. How close are these chords? And, you also might I do this thing called quantizing, okay, which I probably should have done before this. What quantizing does, so these things, they have however many notes they have. They may have lots of notes, all right? Some of them may have a lot of notes. Some of them may, like eighth notes are short notes and quarter notes are bigger. This thing quantizing it, I said, just take whatever's on the quarter note beats, so 4 beats per measure, and ignore any twiddling around you do. And so that's another way to look for similarity. If they're, if they're the same beats on the quarter notes, the same notes on the quarter notes, but different twiddling around, those are more grace note kind of things, and they don't affect the main melody. So I would think that's another one to do that. But I don't have any experience with melodic plagiarism other than probably committing it at some point, but not trying to detect it. All right. So the two parts I have then, one is coming up with some sort of metric, distance metric that tells me pairwise what they are. The other is, given these distances, place them apart. So if these three are 3 apart from each other, I could put them in a triangle and they'd all be 3 apart and it would be okay. And if they were 10 apart from something else, well, that would be over here. Or maybe, it's sort of a spring kind of model, like physical springs or something, or sticks and springs. I want to be 10 away. Okay. Well, I don't know which direction yet until I see some other things. And then in the end, it may not count. Or I may want to cluster them somehow. And I don't know if these distances can tell me the clusters. That's my ignorance of it. All I know is I know how to count a distance measure for them. Now, let's see if I do a Wikipedia search. Let's say clustering algorithms. What I originally started my training to become a information retrieval kind of person, and they do similar things when you find documents and you want to know how closely they match. Okay, semantically, not so much word for word. But you have this notion of cluster analysis, and really there's 2 ways. Let's see. Well, there's a lot of ways. Somewhere they do top down and bottom up. Okay, so a bottom up says just start everybody in whatever position they are, and then find 2 that are close and say, okay, make a little bigger cluster, and then a little bigger and a little bigger and a little bigger until you form these clusters. That's bottom up. Top down is more, I don't know. I'm not sure where the top comes in. I don't remember. Is this the page that has it at the bottom? No. I found some very nice pages. I don't know what I did with them. Nope, those aren't it. Okay. But these algorithms are trying. They're not exactly what I want, but maybe they're, I don't know. See, these things they're good at scanning a 2-dimensional space and saying, like, what are the clumps of stuff? dbScan doesn't mind stuff that's out of bounds. It just says, it's probably noise. And it comes up with the chunks of things. Okay. But I don't have data like this. I have data that's like, these 2 are so far apart, but it's, and I'm not an expert on these geometry kind of things, but one way to look at them is to kind of put them in a multi-dimensional space. And so they're all this close, that close, whatever, on some dimension. You can do a sort of projection from this multi-space down to fewer dimensions. In particular, we could probably get to 2 dimensions, and then one of these algorithms like this would be fine at grabbing this and saying, these look like a clump of related things. Okay. Now, maybe I can define some sort of trivial algorithm that identifies clusters and puts them closer or further away, maybe. Clustering is its own kind of independent thing of that. But I know there's been a lot of work in the last 10 years, like the big data stuff, right? I mean, all that thing has been really come a long ways in the last 10 years. And then same thing on the, well, I don't want to say AI, but large statistical model stuff, for deep data analysis that they've got techniques and algorithms that they put together. I did a brief search to see if I could find stuff in Swift, and I didn't see a lot. And I don't know that I need this, but my thought was do some measuring, figure out the pairwise distances, lay them out on some small dimensional plane or cube or something. Lay them out somewhere, probably two-dimensional. If I laid them out like this, and I had a method to say, like circle this cluster and select those, and then I would go in for a deeper comparison of those. I might listen to each one and say, okay, let's look at the Parsons code for them and just see what they look like. And, do those shapes look similar? And that would help me get the noise out. That this one, flat as it is probably not the same as this one with the mountains. Okay. And give you an interface where you could kind of zoom in on little clusters of stuff. I don't think I require that you algorithmically identify those clusters. I mean, if I had the raw data, I don't know if we have a black and white one somewhere. No. Maybe a little in this. All right. If I had this data, I would try and, I might by eye say, oh, this looks like a clump. And maybe this looks like a clump. And I could do that. So I'm willing to kind of evolve my way to the solution. All right. So I was not expecting to do this today. I thought we'd need about another hour on the metadata stuff. All right. So my inclination at this point, I would like to be able to give you two Parsons codes, and you give me back a distance measure. Yeah, Python. Oh, those guys are all over it. Yeah. And I don't know, maybe I should, I don't know. I don't mind implementing one kind of crazy algorithm for this stuff, but I would really rather find a library for it. And I'm doing the whole thing in Swift, so I don't know. I don't know if I can even call out to Python easily enough. But yeah, they've got tons of this stuff. I mean, I don't know. I ran across dozens just in a 15-minute search, and so I'm sure there are hundreds of algorithms out there. But that DB scan that got mentioned over here, that definitely is a popular one. Let's see where to go. This one. Okay. Oh, density based. I don't know what the rest of it is. Nah, density based something. But it's looking for some control over that. I learned these, let's see. I don't know. It's called agglomerate hierarchical clustering. That's probably it. Okay, yeah, agglomerative is bottom up, where I was saying start them in pairs. This one, I guess, top down, we're just kind of saying like what section has the most intense links to each other. Single linkage, clustering. And notice these algorithms are on the slow side. Order n cubed, order n squared memory. I mean, I might have 100 songs. So n squared is 10,000. I definitely don't want anything that's 2 to the nth. Okay. And I don't really need perfection. Okay. I don't need exhaustive search where we try every possible arrangement of all these things. It's just a little bit. This to me, this hierarchical clustering, you're saying if in this diagram, the distance between B to C is like 1. So B and C form a cluster. Same for D and E. F's a little closer to DE, so it goes in that one. A is out there far away. And so we've got the clusters of these different things. I mean, something like this would be perfectly fine for me too. It's just I need some way to give an analyst, a musicologist, some handle on which of these songs belong together. and they can research more deeply, look for common phrases, maybe analyze the lyrics, whatever they can do. But yeah, this dendrogram hierarchical clustering, I've seen this done. What was it? Those education videos. I think he did one of these where he did with animals. But this definitely it has that flavor, that foal and horse definitely are close, like the closest two. But if you do that one by one, you're going to miss, A, B, and C that link together. So I don't know. But I think what I want to do, well, probably what I'll do is do some reading offline on the algorithms. But I know I need this distance measure, so let's start calculating that thing, even though we're kind of going in the middle and grabbing a piece in the middle of a problem. Maybe that's not a. We could minimize that algorithm too. I don't know. Let's dig in and see what we get. So I want to give you two Parsons codes. You give me back a number. I don't know how I want to say a percent likelihood that you're the same or something like that. Okay. So I think if we do a 0 to 1, then it's a probability kind of thing. And that's okay. All right. So let's find Parsons. Parsons code. Now this, all right. So the Parsons code, we give it notes, and it produces this DRU thing. All right, when we call analyze on it, data code produces a pair of ints. Wait, analyze gives me this string. That's the thing I want. What is this? Data. Oh, that's sort of the interpretation of it over time or something like that. It's where we're getting our graph, put it that way. X is, 1, 2, 3, 4, 5, and then Y is the value at that point. All right, so let's start. Well, what are we going to call this thing? I think I'll call it clustering for now. And, I don't know, it's probably a transform. I think it's a kind of transform. So we're going to analyze these things, provide you a way to select a subset, and then that's what you use for further analysis. So we're sort of it's a filtering kind of thing. Okay, so sync and then transform. Filter, let's call it cluster. I may regret the name, but I got to start somewhere. All right, and let's do some tests. Pipeline transform. We'll see if we can get by with just a file. So test suite, we'll call it cluster tests. Okay. Now, what this is revealing to me is my parser, my Parsons code, it's a string. Okay, so I think maybe our first step is going to be some cleanup there. Well, let's clean up this first. All right. First thing is they formatted funny. Okay. Let's just run this, make sure it's, I always forget this. I've tried to set this up for iPad. As well as Mac OS, and I pay for it every time I create one of these things. All right, this should just, everything should be back to normal. Yeah, empty method. Okay, I can live with that warning. All right, but let's go back to ParsonsCode. Coder. ParsonsCode. I kind of feel like you should be passing these symbols in. And then you can ask me for the data. Okay, so let's do that. I think anybody who calls analyze, well, who calls that? Tests and this and a definition. Okay, I think that's okay. So let's go here. If you call parsons.analyze report, no, string. I think as string is the method we want. So, all right. There's not a lot of calls, so I'm just going to create the init, func init, which takes notes of symbol. And for now, I just have to add those in. Oops. I'll have to add it to the caller to pass that stuff in. Well, and analyze. I'm going to say public var as string of type string is, no, I'm not going to do that. I'm going to make this work first. Small bytes. All right. I should have a bunch of callers that don't pass in their notes. Okay, this is the one that really counts. Oops. Where'd it go? Okay. I want to pass it in here. I'm going to leave it on the other one for now. Oh, wait. This should be notes. The notes are coming in. Notes. As long as I name consistently, I'm probably pretty good. Okay. Yeah, there's that one. Tune. Okay, so let's, well, we can, hopefully the IDE will do it. It's a little picky sometimes. variable. Let's call it notes. All right, now I can move this one down because nobody's referencing it before now. Coder is that. We got to pass in notes here. And my to-do should be, first thing we're doing is make ParsonsCode a real object. And then we're going to define, oh, well, I guess that's what that is. Usually I put these on the bottom, and they're kind of a stack. And then after the name, they kind of are a queue. All right, notes cannot convert. Oh. Empty tune. I'm going to diff this and see what we had before. ParsonsCode tests. Equal notes. It was the one note and the zero note. Data for empty tune. Okay, we used to just create a ParsonsCode and data subcode. Parsons.analyze. Oh, data is different. Okay. Well, we got the notes by parsing them, but here, this is empty. So I think we can pass that. ParsonsCode takes an array. Okay, yeah. That one should be fine. This one, a one-note tune. Yeah, I remember how note works. Note. Note name character. Accidentals defaulted. Everything's kind of defaulted except the note name. Okay, create a ParsonsCode with one note, and that should be fine. Okay, I'm going to make this one more like the one up here. What I did in this test was I shortcutted. You didn't actually have the notes. You just assumed you knew what the code was. Okay, so let's see. Down D is the star, down to C, another C is a repeat, D, E. Okay, so star, down, repeat, up, up. Okay. That should have that code. So I think this should be analyze notes. Code equals parsons.analyze notes. Okay, let's make sure this one passes. Okay, and they all should. All right, and then let's get this cluster test. I'm just going to say ignore for now. I don't mind the message, but I just want to make sure I know why it's there. All right. So what we've done is we make ParsonsCode take the notes in its constructor. Okay. Now I want ParsonsCode. Well, let's store these. Yeah, I think pitches is array of symbol. Let's store it. Okay. And then I want a string. As string is a string. Should this be description? Maybe it should. Let's make this custom string convertible. Okay, that says we promise to have a description, and I think this really is a text string description of the thing, so it's good. All right, and we're going to return analyze of pitches. Okay, that should be okay. No difference. I'm not calling it. Okay, but now I'm going to make this private. And see who breaks. All right, so we call analyze. We want to say coder.description. And that should work. Oh, the tests that do it. Okay, so this should be coder.description. I think I got them all. So we're going to call parsonscode.description rather than parsonscode.analyze. All right, and now I can clean up inside here a little bit. So the pitches, that's determined when you create the thing. So let's copy this up. Self.pitches equals notes.filter notes only and map it. Okay, so we're ignoring rests. Oh. Why can you not do that? Can't convert pitch. Oh, these are pitch now. Okay. Analyze. Well, let's make pitches array of pitch, and then this is already done, so it goes away. All right. Now, we know this is private, so nobody's calling analyze. Do we care? Data is based on the contents of that string. So let's calculate this here. Let string be of type string, and let's assign it string equals analyze of self.pitches. And then we'll return it here. Let's call it ParsonsCode. Oh, I hate this, hate this, hate this. Okay. Well, I think I can do this. Is that going to work? We'll start it empty. Oh, aren't you annoying? Well, okay, even more so, I don't need it. Let pitches equal that. ParsonsCode. Oops. All right. Now I can't call analyze. I don't know what this message is on about. I don't have an empty line before closing brace. Okay, immutable value ParsonsCode can only be initialized once. Yes, okay. He's still not going to be happy. Okay, self is used to call analyze. All right, now let's make this static. And call ParsonsCode.analyze. Okay, am I back on track? Okay, so I compute the string from the pitches. I don't know if that really helps anything, does it? Let's just pass these in. And put this back like it was. And what we did was we make the constructor compute the Parsons code string rather than on demand. Okay. Now, that is how people get it. And I think this should be I don't think you should have to pass in the code here. Okay. The code string is the description. So we have the data to do it. It's just there. So let's say if somebody asks for data, let's see who's doing that first. They should all have a Parsons code around at this point. Yeah, coder.description, and they're passing it in. Well, let's let coder just return us the data. So I'm going to make this, I'm going to make it as data, public var as data. How about as pairs? Returns this thing. Okay, so anybody who's calling data, I'm going to say return, well, let's say return, can't spell it anyway. Let's return data with description, okay, because that's the code from this object. And anybody who uses this could use this. And it's not very many places. So coder dot as pairs. Not the best name. Okay, and then this is not being used. Right? Nope, it is being used. Parsons code is being passed along. Okay. Coder description and data. Well, okay. I mean, I guess that's a small job, but it's his job. Okay. And let's see, who else is using this? Parsons.data subcode. Well, that's really just Parsons.as pairs. This should be Parsons.as pairs. Code is no longer being used. Data subcode should be as pairs. Code is not used. I'm liking this better for sure. Get a bunch of notes, pass into the Parsons code, do some stuff with it. All right. And what about you? Okay, I think I got them all. Well, messed up one of them. Empty tune. Assert true failed. Parsons code. Oh, I don't know what an empty tune does for a Parsons code. Should be an empty string. I guess it's $1 a pound. One of these. I guess they're the same then. I don't know. This is kind of a weird case. It doesn't really happen. So I can kind of feel like I can define it the way I want. We checked up here. Empty tune is just a star, so that sort of says we're going to get one note, one Parsons code entry, and so it should be 0, 0. Okay, I gotta do this. Okay. I don't know why that's not done for you. They do it in simple structs, and pairs of simple things look like simple structs to me. All right, provide as pairs to get graph data. All right, we're getting there. All right, now this function, analyze as pairs. Well, nobody's calling it. Only this class. So I can inline it. And code is only referenced there, so there's no point in having that. Okay. We've got as pairs returning a result based on the descriptor. This function no longer used. Should all be good. All right. Make ParsonsCode a real object. I think we've done that. Define a similarity measure. Okay, now we're getting into our test. Let's test. Distance of equal tunes is 0. Okay. Now this is where I got to do a little extra work. Is this annoying or worth it? I need notes. Now, what did this test do? I think he had a little constructor. Oh, just that. Okay, I can do that. It's a little work. All right, so let's just make up something. CCD, D, E, D, A, B. Okay. And let Parsons 1 equal Parsons code of notes. Parsons 2 equals Parsons code of notes, same notes. I think I want that. Distance doesn't exist. Now, is this an attribute of Parsons code? Let's put it there for now. I could believe we'd want something pluggable for this or whatever, but public func distance to other is a Parsons code, and it returns probably a double is the easiest thing. All right. And we'll just return -1. This test should fail. Okay, that's our failing test. Yes. All right. Now, I'm going to do a little different. I think I want to make this more like the probability of a match. I'd like to make this 1.0. And then somebody can turn that into a distance if they need to. Subtract it from 1 or something like that. All right, it should still fail. Okay, so I'm going to start very simple. All right. We're going to return self.description equals other.description. If it is, return 1.0, otherwise return 0.0. Okay, now all right, let's get more complicated. Distance of so this is not a distance, it's a match. Match probability. Probability is overstating it. Match similarity. Okay. Now, I'm going to get, let's make notes 1 and notes 2. All right, so this is 1, 2, got to count the gaps. 1, 2, 3, 4, 5. Let's leave out that. Okay, and I want these maximally divergent. Match property of totally divergent tones is 0. Tunes is 0. Okay, so match similarity. Well, I'm going to keep working on this word. I'm just going to call this similarity. 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 It's tough to find the right word sometimes. Okay, I'm happier. Similarity of totally divergent. Okay, so C goes, well, let's just do it like this. D, E, how about A, B, C, D, E, F? A, O. I've got my 7-note scale. Maybe I should just do 2. So 2 notes going up. So one's an up, one's a down. Second one's an up, second one's a down. And I think okay, and I'm going to put the other one in too because I want to just do the thing. All right. How about partially? This may be 1/2. I don't quite know. We'll see what we think. All right, but if I do CDE, so that's up, 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 and I do somebody else that just sits there, CCC. Okay, that should be a 1, a 1. The maximum, that's 2 total, but the maximum is 4 because it could have been 2 at each position. So I'll say that should be a 1/2. And fortunately for us, a 1/2 is a comparable thing, so we'll be okay. All right, so I got these 2 tests reflecting these differences. And I hope the notes, I'm interpreting them correctly. We'll see. Okay, yes, both these tests should fail. I should say that. 0 and 0. Because right now our answer is they're the same if they're not totally divergent. Okay, if they're perfect match, it's 1, else 0. Okay. But what I want to do is let's calculate the total gap. And I think what I want to do is let pairs is zip of self dot description with other description. Okay, so that should give me a list of single character. Oh, I'm getting strings. Don't know if it walks through them or not. Okay. I'm gonna look. Swift convert string to array of characters. Oh, is it just array? Yeah. Okay. And this should be 2 characters. String.element should be character. All right. So I'm going to calculate. Well, let's take this out for a moment. Total gap is 0 to start with. All right. So if I take the pairs, I'm going to take the 2 pairs and switch on them. And I've done this before somewhere. Was it in here? Where was that? It was in ParsonsCode. You can switch on both these. So I can say case star star. There's no increase, so I'll just do a break. Okay. And, well, maybe that should fall out. I don't know. All right, but theoretically, they'll never line up star to star. So my choices are down with down. Is that wrong too? Oh, man. How do you do that? Yeah, that's where we did it before. No. This. Switch this. I guess I've got to put it in a pair, but I think I'm going to get burnt by that. I don't know. We'll see. Okay, well, let's do that. Let's get all the cases listed. Okay, if you got down, 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 repeat, or down, up, then you have repeat, down, repeat, 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 up. Then you have up, down, up, repeat, and up, up. Okay. And then finally, we have case anything else, and that one is definitely a break. Okay, so at the end, oh boy, let's make sure zip only keeps the shorter, right? It should. If they're different lengths, the result is the same as the shorter. Yes. Okay, good. All right, that's kind of what we want. All right, so here, okay, so let maximum gap is twice pairs.count. Oh, come on, you can't count it for me? Pairs dot. Really? Okay, well, let's just make number of notes. Okay, and so the similarity well, the total gap is twice the number of notes. So I think I want to return if I took the total gap turned out to be 0, then it was a perfect match. So that should be a 1. So let's take 1.0 minus total gap. Let's call it gap divided by 2 times number of notes. Okay, so if you have, well, I changed the name for 1. Okay, fine. Now this gap. It is an int. Okay, so let's calculate that appropriately. Make this double of gap divided by 2 times double notes. Okay, I guess I don't need this one. Okay, so the cases then, this is a 0. If they're the same, it's a 0. A down versus a repeat is gap plus equal 1. Let's You don't need a break if you only have one line. Okay. Down versus up is a 2. So that. Okay, so down, down is 0. This is 0. This is 0. Down versus repeat. Down versus up is 2. Repeat versus down is a 1. Repeat versus repeats is 0. Repeat versus u is a 1. Up versus down is a 2. Up versus repeat is a 1. Okay. Let's see if we got it right. Yeah. No. Okay. We appear to have broken everything. And that may just be where we pick up tomorrow. I'm curious what the values we got are, though. Cluster tests 1.0 nan. Divided by 2. Okay. Minus infinity. I'm dividing something poorly. All right. 60 seconds to figure it out. Twice the number of notes that I never incremented. Yeah, that one. Okay. And we need to check an empty case. Well, we can have never have number of notes. Include a single empty line between cases. Okay, well. 2/3. I got to assess. All right. Okay, well, that gives us somewhere to start. We'll start there tomorrow. So tomorrow, Tuesday, it'll be 2 to 4:30 p.m. Eastern Daylight Time or 6 to 8:30 p.m. UTC. Thanks for joining. Hope to see you back sometime. Take care.